How's it going, everyone? So this is the first lesson in the probability unit. This lesson is going to cover something called probability and odds. So probability and odds, they kind of mean the same thing. They just are kind of like formatted slightly different. So we're going to run through just some basics on what is probability, and then we're going to see how it compares to odds. So for probability, if we're doing some kind of experiment and there are n equally likely outcomes, so just like some random number of outcomes, the way that we write probability is we write how many possibilities there are of a particular outcome over just the total number of possibilities that there are. So this is also called theoretical probability because theoretically that is what should happen. So there is an example here of rolling just a six-sided die. So I have one here, and I assume everybody has seen one of these before, but just in case you haven't, there are the numbers from 1 to 6 on it. Okay, so if I were to roll this, well, without even rolling it, what is the probability of getting a 6 on one of these dies? Well, there are 6 possible outcomes on the die, everything from 1 to 6. And there's only one number 6 that is actually on this die. So the probability is just 1 out of 6. All right, very straightforward. Now that's theoretically what would happen, but what would happen if we rolled this a number of times? Would we get, say we rolled it 6 times, would we get a 1 and a 2 and a 3 and a 4 and a 5 and a 6? Like, would we get one of each number, or would we just randomly get different numbers? So that's kind of the difference between theoretical probability and what is called experimental probability. So experimental, like if you think of science, you're doing experiments. This is what actually happens when we do this particular experiment. The setup is still the same. It's still some number over some number. Only now my bottom number, my denominator, is going to be the number of trials. So the number of times that I actually did something. So we're going to take a look at a second example here. We're going to roll a die 10 times, and we're going to record the results below. So we've already got this table set up. So let's go ahead and roll it. I got a 1 on the first, a 6 on the second, a 4 on the third, a 4 on the fourth, a 6 on the fifth, a 3 on the sixth, 2, 5, whoops, that was a 4. I know it's off screen. That's also off screen. I got another 5. Okay, so those are our 10 results. And in this case, it actually ended up kind of being equally likely. We have 1, 1. We have 2 6s, we have 3 4s, we have 1 3, 1 2, and 2 5s. So it's like kind of worked out a little bit, but it's not exactly 1 out of 6 for each of them. So based on the trial that we just did, what is the experimental probability of rolling? It says a 7. There's no way to roll a 7 on a die like this. So let's change it to, I don't know, a 4. Okay, so how many 4s did we roll? We rolled 3 4s. And how many times did we roll the die? We rolled it 10 times. So the probability based on this experiment was 3 out of 10. If we did it again, we'd probably get a different probability. Based on the trial, what is the experimental probability of rolling an even number? So I rolled an even number here 2, 3, 4, 5, 6 times. So that was 6 out of 10. And if you can, try to simplify your fractions. So we can simplify that to 3 over 5. Simplifying fractions is something that you learn in grade 9, and hopefully you remember how to do it. But if not, feel free to ask. There's one more note here at the bottom that says generally we write our probabilities as either fractions or decimals. So we could have written these as decimals as well. To change a fraction to a decimal, you just divide the top by the bottom, but it's much easier in something like this to just write it as a fraction. And also keep in mind, probabilities, they're always going to be a number between 0 and 1. So there could be, for example, a multiple choice question on a provincial exam that says, which one of these probabilities is not possible? So you'd probably be looking for a probability that is greater than 1. just for example. Now this is probability, so how does that compare to odds? And there's two different ways that we can write odds. There's also two different ways that we can write probability that we didn't talk about on the last page. So there's something called odds in favor and odds against, okay? Odds in favor, what it is the ratio of the probability that something will occur compared to the ratio that it will not occur, okay? So odds in favor looks like this. Number of ways something can happen, and then 2 dots, and then the number of ways that it can't happen. Odds against is the same thing, just flipped the other way around. So will not occur comes first, will occur comes second. So this is just the flipped odds in favor. Favor, okay? And why these two numbers are important and how it compares to probability is if we add these two numbers together, that makes up the denominator of my probability. Okay, so if, say for example, will occur is m and will not occur is n, you can pick whatever numbers you want to represent them. The odds against event A are happening, means we just flip them around, just like we said, flipped the odds in favor. The probability of it happening is m, so the number of ways that it will occur, over m plus n. We just add these two numbers together. And I'm just going to write a little table here at the top just for reference. And in my opinion, this would be a good thing to write on a cheat sheet. So we have the probability for, the probability against, the odds for, and the odds against. So I'm just going to kind of write down here what that looks like in terms of the numbers. And maybe I'll use this m and n again. So my odds for are m versus n. My odds against, we just flip that around. My probability for is the number of ways that it can occur, so m over m plus n. And my probability against something happening is n over m plus n. So again, not something necessarily that you have to remember. Again, I know that there are no numbers, we're just using letters here, but it still might be good for a reference point for you going into a quiz or a test or that provincial exam. So let's take a look at example 3 here, which says when we roll a 6-sided die, determine the odds in favor of rolling a 4. And then how is that different from the probability? So again, if we were to roll a die, there's only 1 4 on the die. So the odds in favor would be 1. And then how many ways can we not roll a 4? There are 5 ways that we don't roll a 4. So this would be the odds in favor compared to the probability. So I'm going to just write OF for odds in favor, whereas the probability for would be 1 over 6. And again, the 6 comes from, well, either you can think of a 6-sided die, or like we said up here, you add your two numbers together to get the denominator down here. All right? Example 4. Research shows the probability of having twins is 1 out of 32. What are the odds in favor of having twins, and what are the odds against? So once we figure out the odds in favor, odds against, we just flip it around. So the odds in favor, well, there is one way that we can get twins, but then the other number to get the, I guess, the will not occur, remember 32 is my total. 1 is the number of ways that it can happen, so 31 is the number of ways that it can't happen. Okay, so it would be 1 to 31. And the odds against, like I said, we just flip those numbers around, so it's going to be 31 to 1. Example 5, you have $5, $10, and $20 bills in your wallet. The probability of getting a $20 bill is 1 out of 15. What are the odds in favor? What are the odds against? Again, this is very similar to the previous question. The odds in favor, well, my first number is my numerator, so 1. My second number is we just subtract the total minus the number of ways it can happen. So in this case, it is going to be 14. So 1 to 14. And then the odds against, we just flip that around. So 14 to 1. Example 6. The odds against being selected for a certain job are 58 to 40. What is the probability that you will be accepted to the job? Okay, so the odds against is 58 to 40. So the odds for getting that job is 40 to 58. And now this number here, the first number in the odds for, is the top number in my probability for it happening. So my probability for it happening is 40 over, we add our two numbers together to get the total in the denominator. So 40 over 98. And again, like I said, if you can simplify your fractions, maybe try to do so, but it's not necessarily that important to simplify your fractions, especially in this particular case here where we have a couple of big numbers. We have one more example here which says a hockey game has ended in a tie after a 5-minute overtime period. So the winner is going to be decided by a shootout. The coach is trying to decide who should go first in the shootout. So there's Evan and Brock, and their stats are here at the bottom. The coach would prefer to use the best scorer first, so who should go first? So Evan, his probability of scoring is 8 out of 13. And Brock, his probability of scoring is 10 out of 17. Again, these are not the theoretical probabilities, these are the experimental probabilities of what has actually happened. But it's really hard to compare these two fractions. So what we could do and what we should do is either change it to a decimal or change it to a percentage. And I don't remember if I have said this in any previous videos, if you've watched any of the previous videos, but on the provincial exam, they always want you to round your answers to 2 decimal places. Okay, so the way that we change it to a decimal again is we just divide, numerator divided by the denominator. So we get 0.61538, blah, 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 blah. If you want to change it to a percentage, we just times that number by 100, and we get 61.54%. Okay, so I just took my decimal and I rounded the 3 to a 4 because the number that comes after is 8. Again, that's more of a skill from years before, so I'm not going to get into how you round your numbers. The other one is 10 out of 17, which we can already see is a smaller decimal and a smaller percentage, but in this case it is 58.82%. So who should go first? Evan should go first. All right, so the main takeaways from this lesson are, I would say, just kind of understand what probability is, understand the relationship between probability and odds, and then just critical thinking of how do you approach these problems and what are they asking you, and can you find the probability or the odds when you are asked.